Hello everyone, welcome to the final video in our Learn APL with Neural Networks series. Okay, so this is the last video, which means that by the time this video is finished, you will have your neural networks framework, the framework will be working, and you will have this threadfun completed. And what this threadfun will do is what this threadfun will do is create a neural network for you and train it on the MNIST dataset. And so when this series is over, you can just take your neural networks framework and let your imagination loose and just try to apply it to all sorts of interesting tasks that you can find on the internet. Okay, so in order to complete this function, what we need to do is write our training loop. So we need to write a loop in here that trains the network. And in order to do that, we start off with a similar structure. So we're going to have a while loop, and this while loop is going to repeat, while there's data to be processed, and that data is going to be in the chunk that we just read. So we read a chunk from that file, and if there's rows in there to process, we process them. Now let's print a character just to show that things are working, because this can take a couple of seconds, and if my programs run for a couple of seconds without printing anything, I never know if they're running or if there's an error. So let's fix the targets and the inputs, and those I can get by splitting the chunk. And then we want to train the network with our train dyadic operator, right? Now, the thing is, the train operator expects the target to be the column vector that the network wants, but the targets we get are just the numbers, so the digits. And so what we need to do is we need to use the outer products. So if the targets are, for example, 1, 3, 7, 1, 3, then what we can do is we can do a jot.equals iota 10. Sorry, I just can't spell. So targets jot.equals iota 10, and then we get one of those targets per row, much like we have one of each input per row. So what we need to do is, first I need to take a look at the dyadic operator train, because I do not recall the order of the arguments. So the target goes on the left, the input on the right, the net is the left operand, and the derivatives are the right operand. Okay, so yeah. So the target goes on the left. Oops, that was something that was in there from last time. So this is the second time I'm recording this video, because for the first time there was a bug somewhere, and it took me over an hour to find the bug. And I'll fix the bug with you in a second. So I had to clean everything up, and I forgot that thing over there. So we're gonna give the target on the left, and then there's a diffn, much like we did for the testing, a little diffn that's going to get applied to each row of the inputs. Okay, now this target, this can actually be, because this is a matrix with inputs per row, we can actually have here a matrix of targets per row, so something like that. And that's why I have the target mat, which was the target matrix, and you build it with, well, the expression you see over there. So it's going to be the targets jot.equals iota 10. Okay, now what you need to do is, well, both of these come in as rows, right? So we can use the over operator that will apply the training after pre-processing both arguments with the table primitive. And so both the target matrix, both the target, and the input get into this diffn already as columns. And now we can give the alpha is the target, goes on the left, the omega is the input, goes on the right, and then in here we have the train dyadic operator with the network on the left, and the functions, so the leaky relu and the MSE loss on the right. Now the thing here is, This operator does not modify the network in place. It just returns a slightly improved version of the network. So we need to update the network. And we are inside the diffn. So in order to update this network right here, we can cheat a little bit and we can say something like this. We can say net write tech gets. And this forces this assignment to update that name over there. And so this ought to do it. So now what we can do is we can print something when we are done with training. So for example, training complete. And then we need to do, I didn't mean to close that, sorry about that. Let me open that. We need to fix the bug. And the bug is, well, if you want, you can try to pause the video and look for the bug, and I'll give you a hint, it's somewhere in here. Yeah, but what the bug was is, when we give the input to the network and we try to classify the network output, this is not the network output. This is a vector of all the intermediate values that the network computes. So the output is actually the last element of this vector, and only then we can do the peak of the grade down. Yeah, so this fixes the bug, and now we can try running this function and see what happens. And hopefully we will get a network with an accuracy that is much larger than the average 10%. Okay, so this takes a little bit more because there's 60,000 rows to be processed here, as opposed to the 10,000 rows in the testing. So this should be quite close to, yeah. Okay, amazing, amazing. So 0.9, or not 0.9, I never know how to say these numbers in English. Would someone, I don't know. Yeah, so this is 90% accuracy, because we don't multiply, we are not multiplying by 100. So if I were to multiply this by 100, I would get a 90%. So this is actually fairly gosh, all the words, I lost them. Amazing. Oh my god, yeah, this is amazing actually, to be honest. Look at, we didn't write much code, and this works at a decent speed, and we just get a result that's 90% accurate. And with that, I think we will conclude this short, well, not short, there's 42 episodes to this series, I think, but let's conclude this series on that. So on a 90% accuracy, what I challenge you to do is to try to read up on ways to open PNGs with APL and draw a couple of digits on Paint or maybe in real life, and then take photographs of them, resize them to be 28 by 28 pixels and feed them to the network. And I'll give you a hint. You can either, if you're on Windows, you can check the documentation for the bitmap objects. And if you're not on Windows, what you can do is you can go to GitHub and look up, what is it? BMP renderer by Martin Kromberg, the CTO of Dialog. Let's see if I can show the repo that I'm talking about. Give me a second, I'm opening it up. BMP renderer, exactly. Yeah, so this is it. So you can take a look at this repo. There's some code in here that reads images regardless of the operating system you're in. And so you can try to use this, and I'll leave a link in the description. You can try to use this to read your own digits into the network and see how well the network stacks against those digits. And then, you know, just explore, try to make this code better, more efficient, try to play around with these numbers, just enjoy. Machine learning can be really, really interesting. It's a whole new world, and it's a wide world. So yeah, be sure to take your time to explore all of this. I hope you enjoyed this series. Feel free to leave any comments and any feedback in the comment section, or find whatever way you want to communicate with me. You can find me online in several places. So yeah, I hope you enjoyed. I had a lot of fun doing this, and I'll see you next time. Bye.